Welcome to Coders Digest, and today's video we are going to discuss about Dplyr. So first of all, what is Dplyr? So Dplyr is a tool for data exploration and manipulation, and it is fast and you can use it to attain more productivity in the lesser time. What do I mean by that? Because it makes the data exploration, data analysis so fast that it saves you a lot of time. So in this video, we will discuss a lot about Dplyr, all the important verbs or functions which we have in Dplyr, and we will explore them using different data sets. I will give you a brief introduction, and first of that, all before that, I would encourage you to watch this video fully, and if you have any queries or questions regarding this video, please post me in the comment section. So first of all, your first question should be, how do I install Dplyr? So for that, you can use this command, which is install.packages, and you can type the package name, which is Dplyr, or you can use install.packages and you can say Tidyverse. Tidyverse is also a collection of packages. It contains Dplyr, but it also contains multiple other important packages which I will discuss in future videos. So if you want to stay tuned, I would highly recommend you to please subscribe this YouTube channel so that you can get a notification of my upcoming videos. Okay. So now the next question. It is written over here, what data I'm using. So for this particular video, I will use the NYC flights data. That is the flights data of the flights which departed New York in 2013. Okay, so this data includes details about the planes, weather, career, destination, and all those things. The another data set I'm using is US arrest. So this data set contains arrest in US per 100,000 residents for assault, murder, and rape. And so these are basically two data sets which we are using. So now, since I have my Dplyr installed, I will simply load it. I have already loaded it, but let me run this cell again. Okay. So now, first thing first, like first of all, as you load a data set, what you do first, of course, you first print out the structure of the data set, like what columns do you have, what and how it looks. So let me just run this cell. So this is basically the base R approach. You type the command str and you type the data set name and you get the result. So you can see over here that I have this data frame. It shows me that it has 15 observations, means 15 rows of 4 variables, which are murder, assault, urban population, and rape, and so on. All right. So this is the base R approach. Now you may ask that how I can do it in Dplyr. Sure. Let me comment this out and let me run it. So what I will do, I will simply type glimpse. Glimpse is the command which you can use in Dplyr, and it will provide you a more interactive way, and you can get the data type and a few observations and you can see it here. Now you can also write it as like this. So you can either write the function name in front of the dataset, or you can simply use the chaining or piping. So what it does, this is the most beautiful thing about Dplyr. So when you will proceed with the course, you will understand more about this pipe operator. What it does, it passes the output of the left hand side to the right hand side, right? So in the left hand side, we have the USRS dataset. It simply passes the data and applies the function glimpse on that, right? So these both of these are basically the same thing, and we will see it when we will discuss select, filter, and other functions or verbs. So you see that it produces the same output. So with this, now you may be having some idea that what is this piping operator. I have deliberately put it here so that it will help you when we move towards the more complex examples or move more complex functions, right? So now I'm moving towards Dplyr verb or Dplyr function, that is all underscore equal. So this is a very important function if you want to check that. Let us say if you have a sample of the data, then you want to make sure that it is coming from a larger data set. Then you can type all underscore equal. So what all underscore equal does, it checks whether all the rows and columns are present in another data set or the parent data set. So let me just give you an example and that will make more sense. So here, basically I have this USRS dataset, and here I have taken a sample of USRS dataset. So basically I am taking a sample of USRS dataset. So I have written a function scramble data. which provides me a subset of the USRS data, and now I'm typing all underscore equal. So now if I run this, then you see that it says same column names but different orders. So what it does, that since I'm scrambling or sampling the data, what my sample does, what is my scrambled data, if I show you in the console window. So let me just print this. So you see that here my data set is murder, urban population, rape and assault. All right, so now if I print the US arrest, then you see that my column names are not in the same order. So what it does, that it has told me that yeah, everything is same, but the order is different. So basically if I type it true here, and now I say that okay, don't check the column orders, I'm fine with that, then you see that it shows me true. It means that my both of the data sets are same or are from all the data present in this particular section is also available in this particular data frame. So basically you can compare two data frames in this, and it will be very useful. You can see that in one line you can just analyze and check whether both of your data sets are equal. All right, now let us move to another very important function, guys. This is arrange. So by now, if you see that if you want to arrange your data frame by by some different column, descending, ascending, you might have to do a lot of things. Okay, and this is basically we are starting, we are building up the course. So stay tuned till the end, and we will see how fast and how quick it is, and how convenient the Dplyr package is. All right. So now arrange, what it does, that you can arrange your data in descending or ascending order, or by a particular column. So here let me run all these three commands and I will show you. So first I am just arranging it by murder. Okay, so you see that as of now it has arranged in the ascending order of murder. So you see sorry, not here. So here you see that it has shown me in the ascending order of murder, and I have basically just arranged my data. For the second output, you see that I have now said that okay, I don't want it in ascending order. So for that purpose, you can just type descending, your data frame name, descending, and the column name. All right. Now, if I show you the second output, which is generated by the second command, you see that now my data is in descending order by this particular. Okay. Now the second is I want to, let us say you say, well, okay, that's fine, but I want to arrange my data frame based on the two columns. All right. Now you see that it will now arrange based on two particular column, ascend, murder and assault. So basically it find wherever these two are highest, it will arrange them accordingly. So this is basically a very convenient and very important function. We will use it in coming videos, or I mean in the course of this video. Now the second verb I would like to use is case when. So you all might have heard, you might have used case in SQL. So this is basically just an SQL like functionality we get in R or through Dplyr. So now I have written this function, I have written this code, and basically you see that I want to print an even on odd number. Okay. So now I have created a vector of 1 to 10, and then I have written case underscore when. So it is basically just like a case. So whenever a number is divisible by 2, it will say even. If not, it will say odd. All right. And the numbers we have are these vector of 1 to 10. So let me run this cell. And if you see that 1 is odd, 2 is even, 3 is odd, 4 is even, 5 is odd, 6 is even, 7 is odd, 8 is even, 9 is odd, and 10 is even. So basically it will print what is odd and what is even. So this is basically a raw function. You can use this functionality and maybe do some more, write a more elaborative program. So this is basically for the demonstration, and you can understand that this basically prints the output. Now, coalesce is also something which you have seen in SQL. So basically here it will print out the first non-missing pieces. So in the vector A, I have 1, 6, NA, NA5. Vector V, I have NA, NA3, 4, 5. Now if I say coalesce, then you might have seen the output. It prints out 1, 6, 3, 4, 5. Reason being that it ignores all the NAs. So it prints 1, 6, 3, 4, and then 5 is common. So one time it's 5. All right. So this is exactly same as you might have seen in in the the SQL. All right, guys, stay tuned. We will discuss the NYC flight data end to end. So this is basically I am telling you a brief about the some functions which are generally lesser used. Okay. Another such function is cumulative mean. Cumulative mean. You might get an idea that it prints out a mean as per the object count. So first you say that of course the of one the mean is one. Now for two objects you see that 1 and 3 the mean is 2. Reason being that 1 plus 3 divided by 2 is 2. So it is 2. For the second till it will print the mean till third. 1 plus 3 plus 5 which is 9. 9 divided by 3 is 3. Alright. Similarly, here 1 plus 3 plus 5 plus 2 that is 11. 11 by 4 is 2.75. So basically this is the way it will print out the cumulative mean. Between is something that you want to print out whether a particular number is between a range or not. So you can say in 1 to 10 which are or which all are in between 5 to 10. So I have this input 1 to 10. I have a list of 1 to 10. So you see that after 5 you see 5, 6, 7, 8, 9, 10 are within the range of 1 to 10. So it prints true, 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 true for all 5, any number after the 5 as we have written the condition here. All right. Now we are beginning our analysis with the flights data. Flights data is basically, as I've given you introduction earlier, that it is the flights take off by from New York airport in 2013. All right. So let me load this data. And if you want to load it, you need to just simply write install.packages nyc flights 13. I have already loaded it, so I'm not going to load it again. I will simply write library NYC plus 13 just to load my data into my memory. All right. Now I have already printed the head. So let me run it again if you say so. So now you see that it is year 2013. We have month, date, departure time, scheduled departure time, departure delay, arrival time, scheduled arrival time, and distance of a particular flight, hour, minute, how much time it taken, air time, destination where it traveled to, origin, what was the origin, time hour, basically what time of the day it took off. So basically that is how it is data. This data is structured. If you want to get more information over the data, you can surely go type this particular data frame and you will get all the information. So first, so let us know not get into the metadata of this particular data set. Let us go and continue with our analysis. So I am using filter function first of all. Filter is, as you all might be knowing, that we want to filter our data basis on certain conditions, and it makes that is the thing that Dplyr has, that it makes things very, very easy. So let me run this particular cell. I have 3 commands in here and I will show you output of all 3, and similarly I will also uh, tell you as we go through. So here it is running. So let's wait until it finishes. Okay. So on the first command, I have written that I am passing my flights data. So you might have now known that this is basically a piping or chaining operator. I am passing the output of the left hand side to the right hand side. So I am passing my flights data set to my filter command here. And I'm saying that, okay, filter me the data where year is 2013 and month is 2. Okay. So you see that within just this half line of code, this has given me now filtered my data on the basis of year is now 2013 and the month is 2. So all of my data is now filtered, and this particular data frame contains all the data that has 2013 as a year and month as a 2. If you want to store it, you can simply write that let us say tf underscore 2013. Let us say if you want to store this, you can just simply write this particular condition, and this way you can save the Dplyr data. So now if you see that I have created another data frame from this query, so you can just, this is the way basically the R command or the simple R functions by which you can store your data in the Dplyr. So you can store a query's data. And now you can also write filter condition that if you for the, let me run it again for the sake. So let me run this thing again. Let me just make it as it was. Okay, and let me run it again so that I have all 3 outputs. So now for the second line, I have flights and I have used OR condition. So let us say I want to say, okay, just give me the flights where the carrier or the plane was UA or DL. So these are basically the carrier names, United Airlines and The second one, I don't know what is the name exactly of this particular airline. It is abbreviation, so you might check it is there in the metadata. So for the purpose of demonstration, you see that I now have data of only DAL and UA. So basically you can use OR command here. For the third, this way, let us say I'm using the chaining command or piping command. I'm passing the data. You can simply write it as filter your data set and year equals to 2030. You can also use and or. So basically, this is also a way, and it will provide you the same result. So this is for your knowledge. All right. Now, the another thing is in operator. So you can use in operator with the filter also. So now you can say that okay, filter my data where career in, and you can provide your choices. So let us say this is also the same way with the in command. So remember that you need to put it in this format. So you say that okay, filter my data where career in UA and AA, and it will filter out your data. So keep that in mind. Or if you have any doubt, then you can just simply go through and backward forward to find out where what exactly you want. See, all the verbs are there. Okay. Now sometimes you might have seen that okay, you do not want to analyze all of your data columns. You want to analyze, you want your analysis to be limited to a particular subset of the data. So Dplyr makes that very easy, and you can simply write select query and simply write pass your data, write select, and you see that now I have only these many columns which I choose to. And if you want to store this particular data frame, you can simply write like you can simply write data or whatever name, you can store it here, and your new data set will be just with these many columns. So this is basically your select column, select verb. Okay, keep this in mind, very important, very helpful. Now okay, you say that I want to select data on the basis of any condition. So let us say you want to, let us say if in a case of missing value also, you want to treat your categorical variables differently, your numerical variable differently. So let us say that is the way you want to say that I want only my numeric data set or the columns which are numeric. So you say that select underscore if is a condition which, and after that you provide the function basis on which. So I'm using the R inbuilt function is dot numeric, and what it does that it selects the column only when those satisfies this particular condition. So what it does, it basically provides you all of your numeric columns. All right, so basically now you can see that I do not have any categorical variable. You see the destination or career, I now do not have them. It is just simply filtered out my data set based on that particular condition which I have written there. Selecting using containing text. Contains what does? Let me show you. Contains mean that it checks out all the columns of your data frame and figures out whether they matches a pattern or not. So here I have written the select command, my data frame name which is flights, and now I'm saying contains delay, contains time. So what I'm saying here, keep it in mind. I am saying that give me only those columns which either contain delay or time in the name. So those columns which in the name contain delay or time. So you see all of my these columns are either containing time or delay in their name. You see arrival time, scheduled arrival time, air time. So this is very useful, very handy. All right. Next verb, group by. Group by is basically we all have used in SQL or at many places. Like even if you talk about the database, then every database has it. Or in pandas, it is basically a very core of the analysis of any data. So it is used for aggregation functions mainly. So let us say now see again I'm using the chaining, and I'm passing the output of left hand side to right hand side, and this is a classic example. Do pay your best attention here. So I'm passing the flights data to group by, and I'm saying that okay, group by my data from by career. Okay, now after grouping by, you see that I have another operator here. So what I am doing that I am passing now after grouping up by, I am passing it to this, and I am saying summarize it by average delay equals to mean departure delay. So I am saying that create me a new column and say that is average delay, and provide me the mean of departure delay in them, and then arrange that by descending order of the delay. So basically, let me run this and that will make more sense. So here it is. So now you see that I have grouped all my flights by career. So you see no other column. Then what I have done, I have created a new column here. You see that average delay. I have summarized all the flights by delay. And what I have done in the delay, I have said that okay, now provide me the average of departure delay, and I have say any.rm equals to true, meaning that do not consider any NAs if they are available in my column, in my departure delay column. So I have said that okay, group my data by the career and provide me the mean of the departure delay and arrange it by descending order. You might remember that we have discussed arrange function earlier in this video. So if you are confused about that, just go back and check that again. So basically I have summarized my data based on the average delay, that is mean departure delay. So that is very handy, very useful, and see that within a 2 lines, basically it's merely 2 lines, we have done such a great analysis. And now I can say that okay, this is my flight which is highest, F9 is the carrier which has the highest delay. Okay, I don't want to travel by that, right? Or you can see that okay, let us say that okay, don't do it by descending order, let me find out which flight or which carrier has the least departure delay. So you see that US, I think, I'm not sure which airlines is this, but you see that okay, I would like to travel by this because it has the least delay, that is fairly small number. All right, so you see that we have come to a very insightful information. All right, now one is count. So again, I have grouped by my data by career. So basically I've grouped all of my data by the career. And now I have said that, okay, provide me the count, that how many flights or how many flight does an particular career is operating at that particular day or in this particular data set, and then arrange it by descending order. So now you see that United Airlines has the highest number of flights operated. So basically this is career is your airline name, and I have just said that okay, group by career, group my data by career and provide me the count. Then essentially that is what the total number of observation in my particular database based on this particular condition. So basically, and then I have arranged by descending order. So you see that now you can make sense with this data or this output, that what I have done, that now I have basically figured out that which is the highest operating career in my data set, which has the maximum occurrences. So basically this provides you the count, and you can just manipulate it based on your condition. Distinct is a very handy verb, and it is very useful. Distinct is, as you all know, it provides you the distinct number of whatever condition you provide. Let me run this cell. So basically, let me show you the output of the first command, that is in the left hand side. So basically, I have said that okay, take my flights data set and provide me all the distinct destination. So I'm saying that in my data set, what are the distinct destination? Where are my flights departed to? Provide me a distinct number of them, means no duplicacy. Provide me exactly one count of each destination. So basically, by here you can identify that which all are the destination operated. Okay. So basically this is that. And now if you see dot keep all equals to true, what it does, this is also very useful. It is providing you the same output, basically the same destination, exactly one count. Okay, but it is keeping all the other columns also there in the data set. So here you see that I was getting only destinations. Here I am getting all the columns along with the destination. So destination is exactly one. It is distinct, but it is also keeping the other observation associated with that particular record at the same time. Okay, hope that makes sense. Keep this in mind. Distinct, very handy, very useful for the data analysis. Next verb, mutate. Mutate is something extremely helpful. Do pay your best attention here. Mutate is used when you want to create a new column out of your data frame, or you can create a new column, or you want to do some calculation on your existing data columns and want to create a new column in your data set. For example, I have taken my flash dataset, and you say that I want to get a column speed. I want to know what is the speed. I don't have that in my data frame. What I can do, that in I don't have speed, but in the data set, what I have distance traveled and I have air time. So basically that is your speed. Distance equals to distance divided by time. All right. What I can do, I can use the command mutate. Okay, and in mutate I want to say what is the new column name. So I said okay, use mutate, create me a new column speed, and then I have provided my logic. So basically I have said okay, create a new column, name speed, and provide the value as distance divided by airtime. Let me run this. So you see that if I go to the end, you see that I have the speed. Okay. So basically I have created a new column using speed, and I have said the distance here, you can see, divided by airtime. So even if you want to say, then you can use a calculator also, it will be the same output. So basically I have created a new column or new output. Okay, that is very useful, very handy. Just not, I think, a line or a half line of code, and we got such a beautiful column, or it is very insightful. Now if else. If else is basically just as we might have in every programming language have if else. So basically what I am doing here, so let us say you want to say, okay, your manager asks you that give me the flight status, and do one thing, that whichever the flights have departure delay of less than equals to 2, write them on time, and whichever have the departure delay greater than 2, write them delayed. Okay, so you say that you are being general and you say whichever the flights which are having less than equals to 2 as a departure delay, be generous and say that those are on time. This much happens in the aviation industry. So you can use the if underscore else command, and I'm providing my data column flights dollar departure delay. So here I have written my condition. First thing is I'm providing three inputs. Okay, parameters. First is my condition. Second is what will be the condition, what will be the output if this condition is true. Third thing is that what will be the output if this condition which I have mentioned in the first place is false. So if departure underscore delay is less than 2, please pay attention. If departure underscore delay is less than equals to 2, the output will be on time. If it is greater than 2, then it will fall back to this particular condition and it will say delayed. Okay, and that output uh, will be stored in the flight status column. I will create a new column. Let me run this and it will make sense. Okay, so now the new column is created at the end. You see that for the first flight it is saying that it is on time. Let me see if my logic works fine. Let me go to the departure delay, and you see that for this particular flight the departure delay is 2, and that is what I have written here, that if the departure delay is less than equals to 2, say this flight is on time. Let us say that for the second flight I have departure delay of 4, so it should be delayed. Let me see. So for the flight number 2, you see that it is delayed because this condition did not turn to be true, so it is showed delayed. That makes sense. That is what we wrote. Okay. Now we have summarize and summarize each. So what it does, that we have seen summarize already. Summarize each does that it basically summarizes your data frame by more than one column. Let us say, and it will make sense. Uh, anyways, this must be now familiar with you. So let me run this particular cell. So for the first output, we are saying that take my dataset, group it by destination, and summarize it based on mean, on distance, and airtime. So basically, I'm saying that for each of my destination, provide me what is the mean distance and mean airtime. So basically, for that purpose, what we have done, we have grouped by our data by destination. So basically you want to make an analysis that what is the average distance and what is the average air time which usually takes for a particular destination. Very insightful, very handy. Summarize does this for you. So basically what this line of code does, it basically groups your data by destination and provide you what is the mean destination distance and what is the mean airtime. So why you see NAs here? Because our data frame does contain some NAs. I will show you. Similarly, for this particular second, what I have done for the second command here, second query, what I have done, that okay, just do one thing, group by my data by year and month. So for every year and month, group my data, and then create a new column, total flights equals to number of, and basically if you write and this particular command, this particular function, what it does is calculates the count of occurrence. So what it does, basically what it will do, that it will group out your data basis on the year and month, and it will provide you the total number of count. So I have created a function total flights equals to n. This I have written. So what it does, that in a particular year and in a particular month, what are the total number of flights operated. So basically this is what it is doing. It is very helpful, uh, and you can take a, you if you want, you might want to take a look at it more. So you can see this, that what it does, group by more than one column and then summarize it basis on arrange, uh, and arrange on the basis of descending number of total flights. So which month has highest number of total flights. So you can see here that in the month of July 2013 there were highest number of flights, that were 29,425. You might be wondering what I have written here. So it is basically a column function which I was using to check what are the number of, what are the columns which were containing missing values. Basically you see that as I was getting NAs here in this particular columns. So you see that here airtime does have an NA value, so that is why you see N is in the output. So basically this command, what I'm doing here, I'm checking out all the name of the columns which are containing null or NA values. Okay, so you can check it out if you want to. Now where I am using the tally function. Tally function is also a very handy function when you print out the count, and it is you just need to write a single command tally. So basically I am saying sort equals to true. What I'm doing here, I'm passing my flash data group by carrier and saying tally sort equals to true. So basically the same thing I did earlier. I want to say that which carrier or which airline has the highest number of flights. What I have done, I grouped by career, and I have created a tally, and I have said sort equals to true. You can set it false also, then it will reverse the order. Okay, and you see that now the lowest, or okay, so it is basically due to the grouping. So if you want to see it in the descending order, you can write it. So you see that highest is the at the topmost, so it basically tallies your data frame. Now another is n underscore distinct. What n underscore distinct does, it basically provides you the unique occurrences, unique data. Okay, basically it creates the unique distinct count of occurrences. So basically what I have done here, I have provided my flash data, grouped it by destination, then I have saying that okay, summarize this where n underscore distinct career, this is on unique career. So basically I want to know that on each destination, what are the unique number of carriers operated. Let me run this and it will make more sense. So for the destination ABQ, there is only one unique carrier. Okay. Carrier 1 tail numbers are different. Okay. For this particular ATL, you see that unique number of carriers basically are 1180. So you might get an idea that on a particular route, one airline travels multiple flights in a day, even like for New York to California, maybe US Airlines travels hundreds of times in a week, or I don't know. But you want to say that, okay, I don't want 100 occurrences, I just want to know that from New York to California, what is what are the unique number of carriers, what are the carriers which operates. Okay, and I don't want the duplicacy. So these are the unique carriers. Or you say you want to say that I want to find out the destination which have the highest number of unique carriers, I mean which have the highest unique airlines are coming to that particular destination or that particular airport. So this is very useful for your analysis. Okay, I hope that is making sense. If not, if you think that I'm going too fast, please reduce the speed in the YouTube settings, and then maybe you can have a better look. Okay, and please do let me know in the comment section also, so that I can reduce my pitch. Okay, all right. Now we are moving toward joins. Okay, so joins are basically, we all might have heard about is that we want to join more than two data frames. So here I have here created their two data frames, df1 and df2. For the first, I have created a column customer ID where I have randomly chosen or basically sequentially chosen 1 to 6 as a customer ID. In the product, I have created another column product where I have created a repetition of trimmer 3 times and repetition of radio 3 times. Similarly here, I have created the customer ID 2, 4, 6, 10, 4 rows. And I have created repetition of state as New York for 2 times and repetition of California for 2 times. Let me run this, it will make more sense. The output of the first data frame is that I have 1 to 6 as customer ID, Three of my customers have purchased trimmer, as I have created here repetition. Three of my customers have purchased radio. Here you can see. Second data frame, I have created four customer IDs, 2, 4, 6, 10. See it here. State, I have created repetition of New York 2 times, California 2 times. So 2 times I have California, 2 times New York. Okay. So this is my data frame creation. Left join. What left join does is it contains all the rows from the left table and retains matching rows from the right column. So let me see what it does. So you see that for the customer ID 1, we have here customer ID 1 which has bought a trimmer, okay, but in the second data frame we do not have any entry for the customer ID, so it prints out NA. Okay, similarly for the customer ID 2, we have this particular person has created a trimmer and has an entry into my second data frame also, so it print outs here. Okay, so it basically all the rows from the left matching rows from the matching data from the right hand side table, and it prints out like this. Whichever are non-matching, it shows NA. Okay, so basically all the records from your left side, left data table, matching from the right data table. That is what left join is. Now right join. So right join is basically just opposite of the left join. What it does, all the records from the right table matching from the left. Here if you see that I have all the data from the right table, and you see that it is also there in my left table. So if you see in this first column or first table, I have customer ID 246. Okay, and those are also present in my right this particular column. So 246 are here, 246, and in the right hand side data frame you see that we have 246. Okay, but in the right hand side we have 10, which is California. Okay, but I do not have 10 in my left data table, that is my df1. So what it does, it prints out California but shows NA here. Reason being that this data is not available in my left hand data set. So what it does, all the records from the left hand table and matching records from the right hand table. Okay, I know that I'm scrolling and it might be hard for you. You can just go back a little and understand it. Inner join basically provides you the matching rows from both the tables. So you see that 246 are there in both the tables, both the data frames. So if you go over here, then we have 246 in the first, we have 24610 in the second data frame. 246 are the common data, and it has all the rows, all the data in here. So it basically provides, so it inner zone is basically provides you the matching rows which are available in both the data frames. It if it is not there, it will not provide you the in the output. It provides only the matching records in both the data frame, on the left hand side, on the right hand side. I mean, whatever you are joining, it provides the matching records. Okay, anti-join is a very interesting join, and it basically provides you non-matching in the second data frame. So what it does is that it in the df1 it says that okay, data frame 1 I have, and it will provide you whatever is not matching in the df2. So you see that we do not have 135 in my second data frame. Out of this, I do not have 135 in my second data frame. You see that it is missing. So what it does, it provides me the 135, record 135 from the data frame 1. What it does, takes data frame 1 and says whatever in data frame 1 is not matching in data frame 2. Okay, whatever is matching, it will not provide you. It is done by inner join. It is just opposite. It is saying that I will provide you only what which is available in data frame 1 but not in data frame 2. So I do not have 135 in data frame 2. It says okay, let me print that. And so basically it is anti-join. Now we have discussed almost all the important verbs. One more thing I would like to discuss is a sample. So if you want to create a sample, so what you can say that you can write sample underscore n is basically number. What number of sample do you want? So here you see that it provides you the 10 columns, 10 records from the flights dataset. So I have provided my flight dataset as a whole to sample underscore n, and I have given it the count. So what it does is randomly provides you 10 samples from the flights dataset. Similarly, here Let's say if you want, I don't want it by count, I want it by fraction. So there is still a command to help you. There is a command sample underscore frag. So what it does, it provides you fraction. Now you can provide the fraction. Let us say you say I want 25% of my data in my sample. Okay. So what it does that you can simply write 0.25, you can write 0.5, 0.7 or whatever you want. Replace equals to files. This is basically, you might all have come across the term replace, that now whatever record it has chosen in this particular sample, it will not replace it, that record will not occur again. Okay, so basically it is not replacing the data frame in the original data set. So basically it is a unique 25% data. If you want, you can store it, let us say you can write it, you can run it. So basically now you have created your new fractional data of 25% of the flight data unique into this particular df underscore frag. Okay, very helpful. Now rename is another command, and after that we will be done with this video. That is rename. This is also very handy. So in R you have to write a long line, but in this particular dplyr, what you say that it provides you the function rename, and here you say that I want to rename my dest column. You see that in here, if you see that I have my destination as dest. So you say that I don't want, that doesn't make any sense, and I want to rename it as destination. That will be more helpful in me to understand the data frame metadata. So what you can do, you can simply use the dplyr rename verb, and you can say that okay, my new column name will be destination. So let us say if you want to, after renaming, or you can do multiple columns. I have written here only one. After the comma you can write multiple. Okay, so let us say you want to say I want to store this particular data frame in a new data frame. You can write you can use this r operator. And now if you see that I have created my new data, and in this if I show you, then if I scroll here, you see that my dest is now renamed to destination. All right. So here basically in this video, we have covered almost all the important functions which are helpful for you in data analysis, data exploration. Basically, everything will remain the same. You might have a different scenario for you to analyze, but these all are the functions which will be very, very helpful for you. I assume that this video you will find helpful, and if you do, then I would request you to please like this video and subscribe to my YouTube channel, because I am going to make a lot of such videos and I want you to get a notification for them. So please, before going, do subscribe my channel and like my video. And again, thank you very much for watching this video. Thank you.